So the next tutorial is how to build a server. In this case, Express Node.js server. So again, as we discussed before, Node.js is just JavaScript for the server side, for your PC, not for the browser. It's still JavaScript, just as, for example, JavaScript in the browser has additional functions, document.getElementById, and so on. So it has, on top of regular JavaScript programming syntax, it has additional sugar to manipulate the DOM, the HTML, the CSS, and so on. So that's browser-specific JavaScript code. Now, in Node.js, it's still JavaScript, but on top of regular JavaScript syntax, it gives you a bunch of different libraries where you can manipulate local files, create files, delete them, update them, do some other stuff locally on your PC. So logically, you can use Node.js to create servers. But now, what is a server? What is backend? So browser apps is commonly known as frontend. Frontend, something you see in front of yourself, like directly, something you directly interact in the browser. So hence why browser apps are commonly named front-end technologies, front-end developers, front-end code, and so on. Now, back-end code, back-end developments, or server is basically something you don't directly interact with, but your front-end app or the browser app makes HTTP requests to talk to your backend or a server that does something interesting, right? So what is actually a server or the backend? So I'm gonna just quickly draw certain things to just try to visualize what actually happens. So let's say this is our database. And what is a database? So database itself is a server. So let's say a server is basically, imagine installing an application or just a software in your Windows system, right? So that is a software running locally on your PC that does something. But for that app to work, you probably need to click on the icon to open it, interact with that app, do something with it like a Word or Excel or whatever. Now, server on the other hand is also an app running on your PC or somebody else's PC. The difference is it's connected to the internet and it listens to incoming requests, and it gives you some URL you can send requests to. So once you send a request to that specific URL your server gives you, then your server receives that request, sees the URL you send the request to, and then processes that request and sends back a response, maybe some data with the response, whatever it is. So the database itself, imagine it being just, again, another type of server, which basically, let's say you have a blog database. So imagine that being like a folder named blog. And then inside that folder, you have a bunch of different folders like posts, accounts, and so on. And inside of the posts folder, you have a bunch of files, each blog post being a separate file. Just imagine it like that. So basically, what the database is, it's a server which can get a request to write something into the database, or essentially the database being folders and files on your PC locally, and then read something from the database. So for example, I want to write some post. We send a request to the database server with some data and say, okay, I want to save this post in your database. The database opens the blog folder, finds the post folder, opens the post folder, and then essentially creates a new file with the title of that your new blog post, writes some data into that file, and that's it. It's saved into the database. Of course, it's a bit more complicated than that, but technically, just imagine the flow happening like that. When you want to read stuff from the database, you send a request to your database server, and you say, I want to get the post with this ID. And then basically the database as a server takes that request, goes to the blog folder, goes to the post folder, inside the blog folder, and then finds the file with that ID, reads the data from that file, and returns that data to the server or the browser app. And then the browser app takes that data and then renders it on the screen in a React app or an Next.js app. So basically that's how it works. Now, the problem of the browser, let's say this is a browser app, So the problem with the browser app directly interacting with the database is security issues. Imagine you leaving, so in order to connect to the database, you get a URL, and in the URL you have a username and then colon, and then you directly embed the password, and then whatever the database link is, .com, whatever. So this is, for example, sorry, my drawing skills are awful. So basically, this is like a URL to your database where you directly embed username and password inside the URL in order to connect to the database. So the problem is if you expose this URL in your front-end app, because anybody can see any file of your front-end app directly in their browser. So technically, it's not secure to leave this information in the browser app. So somebody can steal this URL to your database, maybe delete stuff from your database or steal the information from your database. So this is a no-go, right? You cannot do this. So in order for you to interact with your database, write some stuff into it, read stuff from your database, from your browser app, that's where your server comes from. So server is basically, again, a small app running on your PC that also gives you a URL. Of course, you don't put in a server URL, username and password or anything. It's a simple URL that your browser app sends to your server some request. Then the server uses this private URL to the database, but nobody in your server running locally, you don't expose this information. Only your server locally knows this link. So the server makes a request to the database to get the blog posts. Then the database returns the blog post to your server. That server then forwards that response to the browser app. So server basically here is intermediate between the browser app and your database in a way. So in a secure way, you request some data from the server then talks to the database, reads some stuff, gets the response from the database server, gets the data, forwards it back as a response to your browser app, and then browser app renders it on your screen as like a bunch of blog posts. That's it. Basically, that's the entire interaction. This is what it is called like being a full stack developer. Being able to build both front-end apps, browser apps, build a server, use the database, so do all of these things to make a fully useful app. Otherwise, if you're just a front-end developer, then you only do this part, but then you need a back-end developer as well as an employee to build a server, so you can have a complete app as a company or for a project. But if you're a full-stack developer, what I'm exactly teaching you right now, then you do all of these things. And it's not hard to build a server nor to interact with the database, and we already went how to build a front-end app. So these are all individually not that hard. I mean, once you start using them over some time. But yeah, so essentially this is a full stack flow. You build a browser app, a server, and so your server talks to a database, and basically your browser just gets the response in terms of blog posts and then renders it on the screen. That's it. That's the gist of creating a full stack browser app. So now, going back to how to actually build a server. So same as JavaScript is like a raw JavaScript programming language, and React is a framework to make our life easier for building front-end apps, so we don't have to manually create HTML or insert a bunch of HTML through JavaScript into an HTML page. So React makes our life a lot easier to just easily do some React code and then just start our app in the console, and then everything just works, right? That's our app. So the same way, Express is a framework for Node.js. Gives us a couple of methods where we can start our server very easily and then handle our routing very easily, respond to the browser in a very simple manner, and so on. So as we explained previously, what are HTTP requests? So it's a browser standard for establishing one handshake, one-way communication between two different servers, or a browser and a server, and so on. So it's called a handshake connection because a browser sends a request and says, hey, I want to fetch this resource, and then the browser responds, and that's where the communication ends. Next time you want to make another request, then you have to make another HTTP request, and so on. So it's just a request and a response back, and that's it. So the HTTP request standard basically there are three main things to remember. One is you send a request towards some URL, and then there are multiple methods with a request you can type of request you can make, type of request methods, get, post, put, delete, and so on. And you'll see on an example why those matter. And then request body, you can send some request data along with, for example, if you want to create a blog post, you have to send a blog title, blog post text to the server, so server knows what to save into the database. So those are like three main things, right? So just a structure of the URL very quickly to explain. So we have HTTPS and then : // This is a protocol, so it's either HTTP or HTTPS. There are some other ones, but these are ones we are going to use. We will use for creating a server we need. HTTPS just means it has encrypted communication between your browser app and your server. So all the data going to the server while making a request and server responding, all that communication is encrypted, so nobody can intercept that request easily and steal the data you are passing to the server, and server passing the data back to in a response to the browser app. And then you have a myserver.com part, which is a domain. So this is, you know what the domain is. And just this as is same as this having a // So it's a root path. We already ran through that for a React app and a JS app. If you add /posts, now this is a different route. It's called a path name. And in the server, we mention it as an endpoint. So /post endpoint, /users accounts endpoint, whatever, tags endpoint. So these are like different endpoints, and this is a critical term in creating our server, because we will make our server handle all these different routes, different endpoints, and each endpoint, if you send a request to different type of endpoints, we will send you back a response of different types. So for example, if you send a request to /posts, that means you want some posts from the database read and returned back to the browser app. But if you want /accounts, then that in the server will then know that you want to get some accounts data from the database back to your browser app. So based on different path names, different endpoints, we will know how to handle it in the server, what type of information you want in your request. So that's why this is a crucial part for building a server. And then query params is, so you can add a question sign and then key values, basically key equals value, and use ampersand and then another query param and so on. So basically that's pretty much it. You have a protocol, the domain, the path name or the endpoint, and then a bunch of query params if you want to attach to the URL. A request to this HTTPS JSON placeholder type API-code.com/posts. So if you send a request to /posts to their domain, you get array of posts back. And you remember this is like a dummy API that gives us some dummy data, so we use it to render certain things in the React and JS app, like array of posts. Remember this? So basically, on their /posts endpoint, they return you a bunch of blog posts, dummy blog posts from their server. So just very quickly, and basically that's what it's called, API. So we usually use the term for creating a server, essentially a backend. Creating a server, we call it creating an API for your app. API is just application programming interface, and what it basically is, it's same as if you bought a TV and you got essentially you have a remote control, and in the packaging they said if you click a red button on a remote control, it turns off the TV. If you click a green button, it turns on the TV. If you click an arrow right, you turn on the volume. If you click a number 2, it switches to channel number 2, and so on. So the API, that's a term for describing a server, because it's the same thing in the server. It means that we just tell you, if you send a request to our domain /posts to posts endpoint, we will return you some posts. If you send a get request to /accounts, we will send you back some accounts data from the database. So basically, depending on the endpoint you send a request to, and different type of request, the server will handle it in a different way and send back some different type of data. Essentially, that's it. So basically, from now on, we will use terms. We are creating an API, and here are API endpoints we are going to handle. We are going to handle API endpoints for /posts, /accounts, and so on. And let me explain you very quickly the term I used for the methods, like get, post, put, delete. So, for example, if you send a request to google.com or, for example, blog.com, we can say https blog.com, whatever. So if you send a request to /posts and it's a get request by default, we'll send you an array of blog posts, right? But if you send a get request to https blog.com/posts and then ID, what you are saying is you want to get So what you are saying is you want to get post with ID 1. So you want to get a single post back, not all the posts, just one post. So this is called a param. So this is how we will define it in the server. So we are going to say we are going to handle get request for /posts /:ID. So it's like a variable. So any ID you pass in the URL, we will take that ID you put in the URL, and we are going to search the database for that for the post with the ID 1 and return you back that single post with that ID, right? But if you use the same URL, but you send a put request, and you'll see in the code you can easily send put, post, delete, get requests very easily. So if you send a put request, for the same type of URL, for the literally same URL, then in our code, in our API logic, in the server API logic, if you send a request with this URL, with the put method, then we know that you want to update your blog post with this ID. So you want to update this specific post with this ID, or ID 1 in this case. And also with this request, you'll send some request data, for example, title updated. So you will send this along with the request. We will, in our server, get your data. We will get this URL, and because it's a put method, we know you want to update this post. So we will fetch this post from the database, update its title, and return a response saying your post is updated. Basically, that's it. And then, for example, if you want to delete your post request, in our server, we will handle the logic for the method of type delete for this URL. So if this is what server gets, we know that you want to delete your post with this ID because you set it with a method delete, HTTP method delete for this URL. So all these URL, you'll see very quickly in code how that it's a lot easier than it looks here, but basically that's pretty much it. And then one more important thing, which again you are going to see in the code very soon, is when the server or the API responds to the browser app, it sends a code back. It sends some data back, and it also sends some HTTP code. HTTP codes that range from 200 to 300 are like success. It's a success response. So like you successfully did something, you get a successful response. If it's from 400 and above, it's usually error code. So there is some error that happened in your request. For example, 400 is like a generic error code. 401 is authentication failed. You didn't send any authentication details with your request, so you can no longer proceed. We rejected your request, and here is 401 code just to give you some data, some state from the server saying, so you know what happened, right? We tell you 401 code, your authentication failed, you have to send some authentication details so you can proceed with your request. So basically 200 success, 400 error codes. For now, that's more than enough for you to know. Node.js app. So as you see, basically this is pretty much it. We can initiate npm project, just basic JavaScript project, install a few dependencies. Just basically we can install only Express, which is the framework for creating Node.js servers. And then basically this is the entire logic. You call Express, you get the app instance, your server, API instance, whatever. we need to run it on a certain port. So, and then basically we can just define API endpoints. We can define our API routes. Basically, we can say, if we get a GET request on a root domain, we do this logic. This function is called, and we can return some response. Then if somebody, this is how we handle GET request for /post endpoint. So the first argument is whatever the path is. The function app.function is get, post, put, delete. Handle different type of methods for different type of paths or API endpoints. The second argument is a function where you get two arguments, three, but two we are going to use here, request and response. Request is a request object that's coming as a request from the browser app to our server, and response object has a couple of methods, which when you trigger those methods, you return a response. You close this request and officially return a response to the browser app. You can say response.status is 200, and then .json is basically you can send some data in a JSON format back to the browser app. And then at the end of this is just basically defining the API endpoints, and the only thing to actually start the server, to start the API, to start listening for requests, you just say app.listen, pass the port, so it will run on localhost :5000 port, and that's it. Basically, once you start listening, you call the listen method on an app on that port. The browser will the API will start running and listening for incoming requests. That's basically pretty much it. Of course, once we define more complicated endpoints and the logic to handle them, communicate with the database, it starts, to get more code in, which is, rational, of course, but this is pretty much enough to just create a server. Let's see how it looks, how we can do that ourselves. So, Express, so let me see where I'm in my console. I'll say enter the Express tutorial. Let's create a folder, make directory my API, for example, whatever. And we can see that we just made that folder from console. So we can enter that folder, and for example, we can just run npm init. So you know how npm, which is just a registry for libraries, so basically it has a couple of commands, many commands, but one of them we used for React app, like npm create React app, npm create next app, and those commands specifically generate like a boilerplate. So here we can type npm init to just generate an empty project. It basically says what is the package name. We can say it's my API, version, it's our new API, whatever description, entry point, source, index.js, doesn't matter, blah blah blah, keywords, author, anything, blah blah blah. So essentially, my API, if we go here, there's only package.json. And package.json, as we already established, is just a file to keep track of all our dependencies our project needs to run. So all the libraries, plugins, if you will, that our project requires to run. So here, first we can say npm install Express. We want to add that library for creating a Node.js server. So we add an Express. Voila, it's here, dependencies. I usually like to put dependencies at the bottom and then all the other stuff above. So here is basically, so node_modules is basically all our dependencies in one folder. You don't need to look into here, it doesn't matter, it's like a huge folder, blah, blah. So when we install something, it's actually placed right there. All those files we download that we use in our app for each plugin. Anyway, so let's create a source folder, because inside there we are gonna have our index.js, like initial file where we are gonna create our server. So here we are gonna create a start command. So to run any Node.js app, you need to type node, that's a command in a console, node, and then space, and then whatever file that will run your JavaScript. So in our case, it's source and then /index.js. So basically that's so far it. So if you go to the index.js and we say console.log some JavaScript code. So and then we go here and type npm start just to call our command. See that our console just console log this. So Node calling Node on a JavaScript file just says, hey, I want to execute JavaScript in this file. So whatever JavaScript I wrote in that file, I just want to execute it. That's it. So if you just type any JavaScript code we want, it's just going to execute it here, whatever. But in that same manner, we can import Express and actually create our app and start running our server. Mind you, if you saw React and Next.js tutorials, we use this syntax: import something, import button component from somewhere. And this is the browser syntax, but the JavaScript syntax for browser apps to import export. We used export default function button, right? And it's a very nice syntax. It's a newer syntax. Import export looks very nice. In Node.js, however, it's a bit more difficult. They went another different route for exporting and importing things. It's cumbersome. What can you do? Just this is the syntax. Just deal with it, whatever. So we use const, like we define like a variable, and we say express equals, and then we say require. We don't import from somewhere. We say require express, and require express will basically store express library inside of the basically a variable. So then we can say const our app or API, whatever we are gonna call express this, and then basically app.listen. So we can have our port here, const port, port equals 5000. So to start our server, we would say app listen, and look at it in VS Code. It's very nice. They give you, if you type a dot on an app, they give you all available methods. So if you can see that there is a listen method. We pass port, and the second argument is just a function. When the server starts, we can console log something to the console saying console log server API server is running at, and so we can use templating strings, so we can place some variables inside. So we're gonna say https //localhost, and then whatever the port we hard-coded is for our server. So if you do this and run npm start, it's gonna do this. API server is running at here. So essentially it's now waiting for incoming requests. Server is running, but we didn't define any HTTP endpoints that people can send us requests to. So to do this, we can say app get, and we can define a route and say this, and then request a response. It's a function, an arrow function, and basically we can just return a response of status 200, and it's a JSON response, and we can say whatever. Okay. So now we need to restart our server, rerun it again for changes to apply here, and so on. So basically this is what we have. Now, if you wish, I would recommend to install the program called Postman. So Postman is basically simulating not a browser environment, but it's an app that with which you can send HTTP requests. You can define a type of request, where to send it, and so on. So we can send it to HTTP because our server is running on localhost 5000. And basically, if we send this request, this is the response we get from our server. So the same way we would do basically in JavaScript. We would say Axios. We would type Axios. We would say import Axios from Axios. And then in code, we would say axios.get HTTP localhost 5000. and then we would get this same response, okay, from our server. But mind you, localhost is when you're locally developing. If this server, when this server gets deployed online for everybody to use, you would basically get some actual domain like HTTPS my API.heroku, it's a deployment service, heroku.com, whatever. So you would get some kind of domain like this. So this, when it's deployed online, is basically the same functionality as this when you're developing local. So you don't see port here 5000 whatever. This happens in the background, and they just give you an actual readable URL to send a request to. But in the background it looks something like this, right? But because we are developing locally, this is the URL we are going to use, and usually that's why I use port 5000 for APIs, but for building front-end apps I use port 3000, so all my front-end apps are on 3000 port, localhost 3000, APIs localhost 5000, and so on. Just a small technicality. So basically that's it. If you wanna, let me just quickly fetch the, so if you wanna define this example that I made, if you want to do this, then if we send a request to /posts, a GET request to /posts, here, this, so we defined an API endpoint, posts endpoint, and this is the response we get back. Remember then when we sent a request, we get like array of blog posts, so this is exactly the same, we just did it ourselves. We made our own server that returned some blog posts, an array of blog posts that we can get in our front-end app and just render it on the screen. Basically, that's pretty much it. But mind you, if I send post request to the posts, we didn't handle that. There's an error. We never handled that kind of. There is a 404 not found. We never handled post request for posts. So if you define a post request like this for the same route, we can do both, like both get and post, and give it the same logic if you want to. I'm just giving, like, of course we wouldn't, but we can handle both the get and post requests like this. And if we go here and now send a post request, we get this. If we now make a get request for the same endpoint, we get this. Of course, post request for posts is usually reserved for creating posts in the database. So we would get some comments. Look, let's do this. So data. So when sending an HTTP request from the browser, you can send some data along with the request. And here it's stored in the request body. So you can say console log 123 data, and we can even send the same data back. I mean, just for this example. So request body is the data we sent from the browser to our server. Usually here we will take this data, save this data into database, and then return success 200 code response to the browser, right? But here just to console log what's happening. So if we do this and restart our server and we go to the Postman, what we can do is make a post request and then a raw, and then send a JSON object, and then we can say JSON object has to have double quoted properties, and then some log title. Let's see what happened. Oops, nothing happened. Why? It's undefined. So in Express, just a raw server like this, very simply an Express app, it doesn't handle receiving JSON data. Our server, to be able to process the incoming JSON data for the requests, we have to add this line of code. So basically we have to say our app has to use this plugin, which is Express JSON, and we can limit to certain size. So it cannot be bigger than 105 megabytes in size, for example. Incoming requests, otherwise the request would get rejected. Or like 10 megabytes in size. This is the most amount of data you can send in a request towards our server. So basically by doing this, now if you restart our server, now our server will be able to work with incoming JSON data in the requests. And this is why is this not pre-built already? Why do I need to add this line of code? Because Express is just building a server. It's building a server that they don't know if you want to handle JSON data, handle uploading data of a different type, but not the JSON data or whatever. They don't know what different use cases people are going to use Express app for, so they don't want to pre-build a bunch of stuff that maybe someone is never going to use. So if this is basically a line of we want to handle incoming data for our API server, somebody's gonna send some JSON data in the request, then that's why we need to use this line of code so our server is able to process the data. So now if I make this request, voila. So what happened here, console log. So the request body, exactly what we sent here in the JSON, the request body, this is what we got. We console log the data, it's exactly what we sent. We can take that object, JavaScript object, save it in the database, and we return 200 and like, oh, success, you did it. Basically, that's pretty much it. What we can do now, this is just roughly how the servers work. Incoming HTTP request, process the request, send some response back, and so on. You have an example Express app as well in this folder, which is basically pretty much the same thing we just did. Send some response on the root, get root and get posts, send some dummy data as a response back. We listen to the app and that's pretty much it. The task I'm gonna give you is pretty much very similar to this, you can always go back, look at how we did it. The entire point is, it doesn't matter if you copy paste it or whatever, what is important is you understand what's happening, and potentially after trying it many times, you can recreate it yourself. For me, it's the most important part, you know what's happening. You don't need to remember everything in advance and memorize every single thing. That's not what's going to make you a great developer. A good developer understands this is how the communication happens, this is what this one tool does, this is what this other tool does, this is how they communicate with each other, and basically you can easily Google how to create an Express app. You would literally Google the same thing not the same, but very similar probably examples of what I just showed you. It's very easy to Google and implement. The point is to understand what's happening there and the point of all of this, right? Which is not hard, but again, do not memorize everything. So the task is initiate an npm project in whatever folder, install Express as a dependency, and then inside create all that setup code, create a get endpoint for root endpoint, and then return a JSON response, object response, okay, with the 200 statements code. Then create a get endpoint for endpoint/contacts, and then return a JSON response, which is like an array of objects, and each object being a contact. So in each object, you can have like a bunch of properties like number, name, number, email, and then their values can be whatever. We are just hard coding to principle wise. And then API should be running on port 5000, and when you run command npm start in the console, it should start at the server. And then once you in the Postman, if you go get request or slash contacts, you should test your server you just started and see how it looks, how it works. And by the way, to stop server from running on macOS, it's Control-C. Somebody's Control-D, but Control-D completely closes the terminal for me. Let me reopen the terminal. So if I type new terminal here, it's going to open the new one. So usually it's Control-C to close the terminal and start from scratch. Close the server and start from scratch. Anyways, so basically that's pretty much it. Do the task and then let me know how it goes.
A few moments later.
So here you have a solution as well for the task. My own solution is basically pretty straightforward. Again, the same thing we already went. We just, instead of posts, we named the endpoint contacts. It's a get request. We hard-coded some data, return that as a response, and that's pretty much it. Next, we are gonna discuss how we actually set up our database, which we can do online for free, to test our apps and basically directly interact with our database, write some stuff into our database, read some stuff from our database, and so on. So let's do that in the next